Lecture 2.3, Continuity. This is the Grand Canyon in Arizona, taken in 2002. Most of the techniques of calculus require that functions be continuous. A function is continuous if you can draw it in one motion without picking up your pencil. A function is continuous at a point if the limit is the same as the value of the function. This function has discontinuities at x equals 1 and x equals 2. It is continuous at x equals 0 and x equals 4 because the one-sided limits match the value of the function. Some discontinuities are classified as removable. In these continuities, you can fill the hole by redefining the function. In a removable discontinuity, you can cover the hole up with the tip of a pencil, and it looks like a continuous function. Other discontinuities are classified as essential discontinuities. One example is the jump discontinuity. Another example is the infinite discontinuity. And the final example is my favorite discontinuity, and I hope soon to be yours, the oscillating discontinuity. In none of these cases can we just fill the hole with one point. Interestingly enough, in the oscillating discontinuity, if we zoom in and keep zooming in, it still looks just like this. We can't really tell what happens in the center. Removing a discontinuity. This example has a discontinuity at x equals 1. Let's write an extended function that is continuous at x equals 1. If we take the limit as x approaches 1 of x cubed minus 1 over x squared minus 1, we can factor the numerator and denominator and cancel out the x minus 1. Now we can evaluate the function, and we get a value of 3/2. So a y value of 3/2 would fill the hole. So our extended function is f of x equals x cubed minus 1 over x squared minus 1 when x is not equal to 1, and 3/2 when x is equal to 1. Note there's another discontinuity at x equals -1 that cannot be removed. The graph looks like this. Continuous functions can be added, subtracted, multiplied, divided, and multiplied by a constant, and the new function remains continuous. Also, composites of continuous functions are continuous. Here are examples of composite functions. In the first example, x squared is a continuous function, and sine x is a continuous function, so the composite is also continuous. In the second example, cosine x is a continuous function, and y equals the absolute value of x is a continuous function, so the composite function is also continuous. The intermediate value theorem. If a function is continuous between a and b, then it takes on every value between f of a and f of b. In this illustration, x goes from a to b, and y goes from f of a to f of b. Since we know the function's continuous, there are no breaks. It must take on every y value between f of a and f of b. Example 5. Is any real number exactly 1 less than its cube? Note that this doesn't ask what the number is, only if it exists. What we want to know is there a solution to the equation x equals x cubed minus 1? If we subtract x from both sides, then we get 0 equals x cubed minus x minus 1. And we could rewrite that as a function. F of x equals x cubed minus x minus 1. And what we want to know is, can we choose a value of x for which f of x will be equal to 0? If we choose x equals 1, f of 1 equals negative 1. And if we choose x equals 2, f of 2 equals 5. Now, because f of x is a continuous function, the function is continuous from x equals 1 to x equals 2. And for those x values, the y value is continuous from y equals negative 1 to y equals 5 without a break. So it must pass through y equals 0. Since f is a continuous function, by the intermediate value theorem, it must take on every value between negative 1 and 5. Therefore, there must be at least one solution between 1 and 2. Use your calculator to find an approximate solution. Use the solve command. Solve x equals x cubed minus 1 for x. And we can find the solve command with menu, 3, algebra, 1, solve. And the answer the calculator gets is 1.32472, which is an approximation. Functions, commands, and tools in the calculator can often be found in more than one way. If you can't find something, look in the catalog. We will find the same command another way. Solve x equals x cubed minus 1 for x. We press the catalog key and then the letter S, and then we find the solve command. We still get 1.32472. If you press enter, it takes the calculator a while to find the answer because it is trying to find an exact answer first. Use the up arrow to highlight the formula and press enter to make another copy. Now press Control Enter to ask the calculator for an approximate answer, and notice how much quicker it is. If you only want a decimal answer instead of the exact answer for any problem, hit Control Enter.